100 to 400 billion stars in the Milky Way galaxy. Billions, if not trillions of planets. Where are all the aliens? Why haven't we gotten any form of signal from space? Are we some kind of special beings? Are we the first civilization in the galaxy? Or even in the universe, are we the first? These questions come from an age-old paradox, and they have captivated scientists for years. But now we may have found solutions to this paradox. Keep watching to find out the answers. Before we look into the solutions, let's look at what this paradox really is. The Fermi paradox is a paradox that arises from the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of evidence for, or contact with, such civilizations. This paradox is named after physicist Enrico Fermi. In 1950, the physicist with his fellow colleagues, Edward Teller, Herbert York, and Emil Konopinski, were having a conversation about recent UFO reports and the possibility of faster-than-light travel. The conversation moved on to other topics until Fermi blurted out, "But where is everybody?" There have been several attempts to resolve the Fermi paradox, such as suggesting that intelligent extraterrestrial beings are extremely rare, that the lifetime of such civilizations is short, or that they exist but for various reasons, humans see no evidence. The Fermi paradox can be summarized as follows: the universe is vast and old, with billions of galaxies and trillions of stars. Given the sheer number of potentially habitable planets, it seems likely that there should be other intelligent civilizations out there. However, despite our best efforts, we have not yet detected any definitive signs of extraterrestrial intelligence, such as radio signals or other forms of communication. This discrepancy between the high probability of the existence of other civilizations and the lack of evidence for their existence is the Fermi paradox.
I want to clarify the Fermi paradox because I think most people who invoke it don't know the full weight that it carries. So you can do the thought experiment. So Enrico Fermi, the physicist, famously quipped, if there's life in the galaxy, then the galaxy ought to be teeming with life and they would have visited us by now. Where are they? So you can ask yourself, well, how wide is the galaxy? So 100,000 light years. Okay, so that feels intractable. So let's say you never get to the speed of light, but let's say we get to 20% the speed of light. That means you can cross the galaxy in 500,000 years. But most stars are not the diameter of the galaxy away from each other. They're much nearer. So for example, Alpha Centauri's system from Earth, 4 light years away, 20% the speed of light, you get there in 20 years, okay? And you can star hop. So imagine you go to a planet and then it's with a robot, and then the robot builds 2 copies of itself, and then they launch to other planets, okay? And then they say, okay, time to go to more planets. And now you go from 1 planet to 2 to 4 to 8, to star systems. It turns out, if you did that, only going to 2 once you land on 1, it's 2 to the n power, right? So however many years are loaded in your n, you can easily completely populate the entire galaxy in an evolutionary timescale. And so you can do it within tens of millions of years. But the planet is around for billions of years. So where is everybody?
There are a variety of possible explanations for the Fermi paradox, ranging from the possibility that we simply haven't looked hard enough, to the possibility that other civilizations are deliberately hiding from us. Some people have suggested that the paradox may be resolved by the fact that the distances between stars and civilizations are so vast that it would be almost impossible for any 2 civilizations to make contact with each other. Others have suggested that the conditions necessary for the development of intelligent life may be much rarer than we think, and that we may be the only intelligent civilization in the universe. The argument for the paradox was formalized by Michael Hart in 1975, but bears Fermi's name due to the well-known conversation with his colleagues. Hart's paper explanation for the absence of extraterrestrials on Earth highlights the following axioms for the claim. There are billions of other stars in our galaxy that are similar to our Sun. It is highly probable that some of these stars have Earth-like planets. If the Earth is typical, some of these planets may have developed intelligent life and interstellar travel. Even at the slow velocity of envisioned interstellar travel, one could travel across the Milky Way in a few million years. Following this reasoning, Hart argues, the Earth should already have been visited by extraterrestrial aliens or their probes, if they existed. There's a popular equation that can help us estimate the number of detectable extraterrestrial civilizations in our galaxy. It was developed by astronomer Frank Drake in the 1960s as a way to estimate the potential for finding intelligent life in the Milky Way. The equation consists of a number of variables that represent factors that may influence the likelihood of the existence of intelligent life, including the rate of star formation, the fraction of stars with planets, the number of habitable planets per star, and the probability that life will evolve on a habitable planet. So what's the Drake? The equation is quite difficult to understand at first glance. N is the number of detectable civilizations in the Milky Way galaxy. R* is the average rate of star formation in the Milky Way. Fp is the fraction of stars that have planets. Ne is the number of planets per star that are in the habitable zone, which is the range of distances from a star where liquid water can exist on the surface of a planet. Fl is the fraction of habitable planets where life actually evolves. Fi is the fraction of planets with life where intelligent life evolves. Fc is the fraction of intelligent civilizations that develop a technology that allows them to communicate over interstellar distances. L is the average lifetime of a communicating civilization. Subject to the assumptions that give rise to these variables, estimates of the number of extraterrestrial civilizations in the Milky Way have ranged widely from as low as 9.1 times 10 to the power of -11 to as high as 15,600,000. Depending on the assumptions, as many have pointed out, the Drake equation can give a very wide range of values.
What fraction of the total timeline of Earth has Earth had what we would call intelligent life, big-brained life? And what fraction of that period has it had intelligent, the Drake equation, and what fraction of that period has intelligent life with technology? So if you do that, then that gives you a set of fractions that you can layer onto the entire stellar population of the galaxy. And even using highly conservative estimates, you do not come out with us being the only life form around. If you look at the actual map of the galaxy where we have found these 4,000 exoplanets, it's this tiny little circle around. The star has to be close enough to get good data to know whether it has another planet around it. And you say to yourself, gosh, this is what leads to that analogy that comes from the SETI Institute, where they say, if you're going to say, well, how could have we found life? We haven't found life yet. And that's like taking a cup, an empty glass, and scooping it into the ocean and pulling it out and saying, the ocean has no whales from this tiny sample of the vast ocean that you know you have yet to search.
Over the years, so many scientists have attempted to answer the Fermi paradox. One of solutions is called dark forest theory. The dark forest theory is a cosmological theory proposed by Chinese scientist Liu Cixin in his science fiction novel, The Three-Body Problem. The theory posits that the universe is like a dark forest, in which all civilizations are like hunters trying to survive in a dangerous and hostile environment. According to the theory, civilizations are constantly being threatened by the possibility of being discovered by other civilizations, which could potentially lead to their destruction. Therefore, every civilization must constantly be on guard and try to remain hidden in order to survive. The reasoning behind the paranoia is explained in this paragraph from the novel, The Universe is a Dark Forest. Every civilization is an armed hunter stalking through the trees like a ghost, gently pushing aside branches that block the path and trying to tread without sound. Even breathing is done with care. The hunter has to be careful, because everywhere in the forest are stealthy hunters like him. If he finds another life, another hunter, angel, or a demon, a delicate infant to a tottering old man, a fairy or demigod, there's only one thing he can do: open fire and eliminate them. The theory also suggests that civilizations may engage in strategic deception in order to avoid detection and protect themselves from other civilizations. This could include using technology to mask their presence or even pretending to be less advanced than they actually are. The dark forest theory has been cited as a possible explanation for the Fermi paradox, which is the observation that, despite the vast size of the universe and the possibility of extraterrestrial life, we have yet to make contact with any alien civilizations. It suggests that the reason we have not made contact with other civilizations is that they are all hiding in the dark forest, trying to avoid detection. Another solution to this paradox is the rare earth hypothesis. This theory suggests that the conditions necessary for the evolution of intelligent life are rare, and that we may be the only intelligent species in the universe. This theory was first proposed by paleontologists Peter Ward and Donald Brownlee in their book Rare Earth: Why Complex Life is Uncommon in the Universe. According to the rare earth hypothesis, there are several factors that contribute to the rarity of complex life in the universe, including the following. The right kind of star. Intelligent life requires a stable, long-lived star with a narrow habitable zone, the distance from a star where a planet's temperature is suitable for liquid water to exist. The right kind of planet. Intelligent life requires a planet with a stable climate, the right chemical composition, and a protective magnetic field. The right kind of solar system. Intelligent life requires a solar system with the right number and arrangement of planets, as well as the right amount of comets and asteroids. The right kind of chemistry. Intelligent life requires the right chemical conditions, including the right balance of elements like carbon and oxygen. The right kind of biological evolution. Intelligent life requires a long and complex evolutionary process, including the evolution of complex cells, multicellular organisms, and eventually intelligent species. The rare earth hypothesis suggests that the combination of all of these factors is rare, and that this may explain why we have not yet made contact with any extraterrestrial civilizations. However, it is important to note that the rare earth hypothesis is not widely accepted by the scientific community. Another solution is that we have already been visited. There is a popular belief among the general public that we have already had alien visitors, and they helped to construct monuments such as Stonehenge, lines in the Nazca Plain, and the pyramids of Egypt. They may have also left behind technology to help mankind's advancement. There is no credible evidence to support the claim that extraterrestrial beings have visited Earth. While some people believe that there have been sightings of unidentified flying objects, UFOs, and other unexplained phenomena that could be attributed to extraterrestrial visitors, the vast majority of these incidents can be explained by natural or man-made phenomena. It is important to approach claims of extraterrestrial visitors with skepticism and to seek out credible evidence to support such claims. It is also important to remember that the vastness of the universe means that the possibility of life on other planets cannot be completely ruled out. However, until there is concrete evidence to support the existence of extraterrestrial visitors, it is best to consider the possibility as purely theoretical. Another solution is that alien life does not exist and will not ever exist. It is impossible to definitively say whether or not alien life exists or will ever exist. While we have not yet found any definitive evidence of extraterrestrial life, it is still possible that it may exist elsewhere in the universe. The universe is vast and contains billions of galaxies, each with billions of stars and potentially habitable planets. Given the size and age of the universe, it seems unlikely that we are the only intelligent life forms in existence. However, it is also possible that the conditions necessary for the development of intelligent life are rare and that we are, in fact, alone in the universe. Ultimately, whether or not alien life exists is an open question that science is actively working to answer. It is important to note that none of these theories has been definitively proven, and the true solution to the Fermi paradox remains a mystery. There are two possible answers that could emerge from our search for alien life: either we find intelligent life or we only come to more and more silence. Ultimately, it's important to remember that the Fermi paradox is simply a paradox and that it doesn't necessarily mean that there are no other intelligent civilizations out there. It simply means that we have not yet found any definitive evidence for their existence and that there is still much we don't understand about the universe and the conditions necessary for the development of intelligent life. It is not clear whether aliens or extraterrestrial life forms exist. While there are many theories about the possibility of life on other planets, there is currently no conclusive evidence that any such life exists. Many scientists believe that the conditions necessary for life, such as the presence of water and organic molecules, may be shared throughout the universe. However, the distances between planets and stars are vast, and the possibility of intelligent life evolving on another planet and developing the means to communicate with us is unknown. Some scientists believe that the chance of finding extraterrestrial life is low, while others believe it is highly likely. Given the current state of our knowledge, it is not possible to say with certainty where any potential aliens may be located, if they exist at all. The search for extraterrestrial life is an active area of scientific research, and many scientists are working to find evidence of life on other planets or in other parts of the universe. However, it is not yet clear whether aliens exist or not, and it may be some time before we are able to answer this question conclusively. Do you think we are alone? Let me know your thoughts in the comment section. Thanks for watching and subscribe.